course, it's cumbersome to have to verify this sort of change by hand, so let's write an integration test to verify that the links change when users log in. Go to our users login test. Here it is, and go to our guard window, or tab. And let's see, instead of test login with invalid information, let's do this. Let's do with valid information. And this first thing is the same, this login path, but then pretty much everything else is different. So let me get rid of this here. Well, we're going to do something here. Get rid of these here. So we are going to post the login path, but what we want in this case is a valid email and a valid password. That is to say, an email address that actually corresponds to a user in the database and a password corresponding to that user. But here we have a problem because we don't have any users in the test database. So the way to solve that problem in Rails is to use what's called a fixture. We saw this briefly before in lesson 6 where we had to eliminate the fixtures in order to get the test to pass. There was a violation of the uniqueness constraint at the database level. So let's go to users.yaml. This is our fixture. I can show you where it is. It's in test fixtures users.yaml right here. Right now it's empty. So what we want to do is create a user in here that has a known email and password. So the way to do this is with these sort of key value pairs. So this is a hash essentially. This is the key. And you can see the YML ending here, the file name extension, that's YAML. So this is a way to write hashes. This looks familiar perhaps because this is what the debug information uses. So this is the key Michael is the name of the user, and then let's give it a name. Michael example. And the email is michael@example.com. And now we have a problem though, because we'd like to put in a password. Something like this. But this will not work. This is not valid. Try this here. So you can see that our test is red here. And that's because there's an active record statement invalid exception being raised. You can see here what's going on. Table users has no column named password. And that's true. The password is a virtual attribute on the user model created by hasSecurePassword. The thing that exists in the database is password digest. But we can't use password here because this is not a valid digest. So what we're going to have to do is actually add a digest method to the user model. So let's get started with that. I can show you how this is going to play out. We're going to use a special setup method to create a user. So @user is equal to users of the symbol Michael. This pulls the user out of the user.yaml, users.yaml. So this creates a user. We're going to pull it out with this. And then what we're going to do is we're going to post the login path with the email corresponding to the user. And the password, well, we can't actually put the attribute on the user. That's invalid. So what we're going to do is do the next best thing and just standardize on the word password. We're going to say that all users in the test database will have the password of just the string password. So what we want to do here is have some sort of digest, and we can actually put embedded Ruby in here. So this is a digest of some sort. In order to get this digest to work, we do have to drill into the cryptographic hash library that we're using as part of hasSecurePassword, which is bcrypt. Let me just show you how that works. Go here. So I've got a link here to the source code for hasSecurePassword. This is the sort of thing that you wouldn't necessarily want to look at this at this stage, but I just want to show you that I'm not just pulling this out of thin air. If we look at the digest, there is this line here. We can create a password like this using bcrypt password.create, and there's a cost function. So the cost is a reference here to the computational cost. And ordinarily, bcrypt is very computationally expensive, which is a good thing. That's what makes it hard to attack. If somebody wants to create a bunch of hashes to try to attack a website by, say, matching one of the digests in the database, it's just computationally prohibitive. But inside a test, we want the cost to be small because we don't care about security here. What we care about is speed. So this line here is what does that. It calculates the cost. So I'm just going to create a digest method. Let's go over here to the user model. And I'm going to make this a class method because we actually don't have access to a user inside of here. So this is going to be a class method, and there are several ways to do this, but the most understandable at this stage is like this, user.digest. So we'll be able to invoke it just like this. In fact, we can do this here. Just paste it in. So this is what it's going to look like. And we're going to give it an argument. Remember, I said we're going to standardize that all of the users in the test database will just have a password of the string password. So user.digest takes in an argument, which is a string. And then we're going to calculate the cost, which we're just going to paste in. Just paste this in. And I don't like the formatting here, so put in a new line. This is kind of a weird syntax. We will be talking about this later, this question mark colon syntax. But for now, let's just pretend that we learned it by looking inside of this file here. And then we can create a password like this. Do this here. This is the string, and then the cost is the cost. So this takes in a string and returns the bcrypt digest, and so since we're calling here with the password, now this user will have the right digest for that password. So let's save it. And over here, now we can actually get this to work. So we're going to post to the login path, and now we can make some assertions. So what happens when we successfully log in? Well, we should be redirected to the user. Do that with assert redirected to. So this is to the user profile page, so we can just do @user. Remember, that's in here. We're just doing this here. It's not user's controller, it's a sessions controller. So we log in successfully, we get redirected to the user, and now we're going to follow that redirect with follow redirect bang, and that should then render the show page for the user. So after logging in successfully, the link to the login path, that's to say this link here, actually I can't even log out, can I? Let me just do this here. I'm going to open up an incognito window. This incognito window has no cookies in it, so you can see here's the login link. So we want this login link to disappear. So we're going to assert that there is no such link. Remember, we did this with assert select, so that we can look over here. Remember the layout links test, or the site layout test here. So we had an assert select, this sort of thing, root path count 2, that checked for both of these links here, the link of the logo and this link here, the home link. So now we're going to say assert select, the same sort of thing, this ahref equals question mark, and then we want it to be the login path, and there should be 0 of them. That means there aren't any. But we would like to say that the log out path and the profile path, which is the user's path, will appear. So let's look at this. So that's these links here, the profile here and the log out. Let's do those. And we can just copy this here. This is going to be the user path. So you think maybe we could do this, but in this context, we actually do have to say user path. It's a little tricky. Save it and see if it passes. Great, so it's green. That means that this is a good test for those layout links changing. In fact, we can go over here and we can even do this. If logged in and false, can have it skip this. Should go red. There it is. Went red. Because the login link, it should have count 0, but it has count 1. So it's cool.